Hello, good evening, good day, everybody. Welcome to the latest episode of Ask Abhijit. Today we talk about science. So let us see, before we begin, who all is there with us. I can see Nirmit, Upanishad, Komal, Karan, Durga, Geetesh, Haripriya, Prashant, Prasad, Yash, Phoenix, Lucifer, Akul, Abhishek, Kamleshwar, Purobinath, Bonfire, Pratik, SJRIKK, Modi Ji, Amar, Bimla, Swapnil, Mohit, Kabir, Trupti, Vladimir Adityanath, Om, Vishal, Anirudh, Sneha, Suraj, Mohial, Azminor, Akhilesh, and lots of other people. Swadesh, Karki, Prince, Manish, Shiva Rajput, Gorang, etc. Aditi, Swapna, Darna Ranu, and everybody else. Good evening, good day, and welcome to this latest episode of Ask Abhijit. So, let us get into the questions. And today we are discussing science, obviously. So, what's question number one for today? Question number one is by two people, Vishal and Sayan. Is it true that in the future we're going to use small satellite launch vehicle and nano satellite launch vehicle rather than PSLV and GSLV? How would SSLV and NSLV be more helpful? And what do you think of the recent SSLV launch and its failure in the terminal stage? How is ISRO going to benefit from a successful SSLV? So the SSLV is the small satellite launch vehicle. It's a new rocket that ISRO has developed, and it's strangely enough, they've developed a new small rocket. Typically, one would expect that when you are developing new rockets, you would develop more powerful rockets, bigger rockets, rockets that can launch a greater payload into further and further orbits. But ISRO seems to be going in the opposite direction. We are developing smaller rockets, apparently. And what's the rationale behind developing a smaller rocket, a small satellite launch vehicle? I'm not sure if there is an NSLV in the works. If there is, then okay. So why would one build a smaller rocket, develop a smaller rocket? It's like this: you have the PSLV, the Polar Satellite Launch Vehicle, and the GSLV, the Geostationary Satellite Launch Vehicle. These rockets are much more powerful than the SSLV. So let's say you want to launch a bunch of small satellites. Nowadays, we can launch multiple satellites on a single rocket. It's the same, essentially the same technology as MIRV technology, multiple independently reusable vehicles. Right. That is ballistic missiles and nuclear weapons, but it's essentially the same technology. So let's say you want to launch a bunch of nano satellites, 1 kilogram in mass, or maybe small satellites like 50 kilograms, 100 kilograms each, and you want to launch three or five of these. So the total payload is about, if it's small satellites, it's about 500 kilos. What's the point of launching a massive rocket to carry a small payload? A single rocket launch, when it comes to the GSLV or the PSLV, would cost maybe tens of crores of rupees, maybe hundreds of crores of rupees. The GSLV is a much more massive rocket, so that a launch of the GSLV would cost much more than a launch of the PSLV. Now, if you want to launch small satellites, you want a smaller rocket, a more efficient rocket, and a rocket that will cost less, right? So as to optimize the costs for per satellite. Essentially, you want to bring the cost per kilogram as low as possible. And that is essentially the rationale, the reason behind developing a new rocket that is dedicated to launching small satellites and possibly nano satellites. Right. So that is the reason why this has been done. It is a purely commercial thing. The reason is purely commercial. ISRO wants to acquire a bigger share of the satellite launch market. Yes. Uh, ISRO will essentially serve as a taxi driver for various clients and launch their satellites into orbit. I'm not saying it in any kind of derogatory fashion. This is a viable business model. And yes, why not make some money, right? If you have the technology for doing that. So, lots of countries, lots of private companies worldwide need a satellite in position in space to do various tasks. Yeah. And therefore there is a growing market, there's a growing demand for launching small satellites. Nowadays you have these cubesats, nanosats, very small satellites that pack a lot of electronics into a small volume, and they can do whatever is required for a certain kind of purpose, right? So these days you don't have to launch massive bulky satellites. Nations need to do that, but small nations and small companies or large companies don't need to launch massive multi-ton satellites. So for that, it makes sense to develop a smaller rocket, and that is what the sslv is, the small satellite launch vehicle, and maybe an nslv. I'm not sure if that is also in the works, but yeah. So that is the reason why this has been developed. It doesn't mean that the pslv is going to be shelved or the gslv is going to be shelved. When India starts its human space flight program, you can't do that with a small rocket, right? You're going to be launching a capsule that contains that would carry maybe three astronauts. Yeah, that's a large capsule. That would its weight would be significantly large, definitely, most likely over a ton. So you can't launch that sort of capsule on a small satellite launch vehicle. You need ideally the gslv for that. So there are various versions of the gslv also that are in existence, that have been developed, and there is still, I believe, a work in progress. Yeah. So the gslv is not going to be shelved, neither is the pslv. The sslv and the nslv are for a certain kind of launch, a niche market. That's all it is. Now what do I think of the failure? Well, typically when you are developing a new technology, there is a process of trial and error. This launch that happened recently was a developmental launch. That's how it has been portrayed. It was a developmental launch. So when you're see, if you look at the history of the American space program or the Russian space program in the 1950s and 1960s, you will see so many failures, so many rockets that failed to take off, that exploded on the launch pad, or they took off and they missed the target completely. Right? Initially, the success rate was about 20 or 30% the first few years. Right? And then over time, they figured out what works and what doesn't work, and then they were able to improve the performance of the rockets. And that's what happened. So there's always a process of trial and error. So this particular SSLV launch did not perform as planned. I think there was a problem in the terminal stage. It was able to deploy the satellites, but they were deployed in an incorrect orbit, and that's why they are not quite usable. That's what happened. So what will happen now is that they will figure out what went wrong, what is the cause of this failure, what exactly went wrong. They will have the data, the telemetrics and all that, and they will identify the problem areas and they will rectify it. And I hope that this is tested again soon, not 6 months or 12 months in the future. The problem with ISRO, I always observe this, it's because of a lack of budget. I think when something doesn't work well, they wait 2 3 4 years to try it out again. Talk about the obvious example is Chandrayaan 2. Chandrayaan 1 worked well. Chandrayaan 2 was a partial success, almost like 90% success. The lander crashed on the surface of the moon. I was hoping they would send a next mission within 6 months, but we're still waiting for it. This thing happened in 2019. So it's certainly due to a budgetary constraints. That's the reason why it takes so long for them to try it again. You give them enough money, they're going to see. When you have engineers who are working on technology, they want to test it out rapidly, right? That's what makes sense. If you look at the way SpaceX operates, they test things very rapidly. There are lots of tests over a period of months. And even if you look at Blue Origin, they have conducted hundreds of tests of various components of the rocket system, the uh, and so on, right? The capsule that contains the human beings that takes them to space and all that. They have conducted hundreds of tests. In the case of ISRO, it's one test in 3 4 years. It's because of budget constraints. So it's okay, it's fine to fail, but you've got to iteratively improve upon what went wrong, and you need to do it rapidly. So I would like to see the next launch of the SSLV within a couple of months, and hopefully this time they rectify the problem. I don't think that's going to happen in the next 2 3 months, but that's how it should be. So the only disappointment I feel is that there is a budgetary constraint, and the engineers are not able to test out new technologies as rapidly as they would like to. Ideally, I would like to see SSLV launch once in a month, and after a few launches, you perfected the technology. So you launch once a month and you do it for 6 months, then you've perfected the technology. But if you test once in 6 months, it's problematic, and the improvements are very small and very slow. So that is the only issue with this. Otherwise, there are a bunch of brilliant scientists and engineers. So yeah, that's about this. Jay says, what is the role of on the Earth's ecosystem? What will happen if one day all the cockroaches go extinct from the Earth? Are they important in the Earth's ecosystem? Cockroaches, yes, cockroaches, cockroacha. So cockroaches are a species of insect. Yes, insect. There are various species or subspecies of cockroach. I think there are different species. There is the Chinese cockroach, the American cockroach, the Indian cockroach. There are small ones, large ones, different colors, dark colored ones, light colored ones, and so on and so forth. Yeah, orange cockroaches, I believe, and then there's your standard reddish brown cockroach, and so on and so forth. Very interesting insect. Yeah. So, what is the role in the Earth's ecosystem? Cockroaches. Look, every species that inhabits the Earth has a certain role to play in the ecosystem. The ecosystem is essentially, in a way, like a living organism. It exists in a state of equilibrium, homeostasis. So all the different species, they perform specific roles in the ecosystem, and it is this combination of millions of species performing various roles that keeps the ecosystem in balance. So what about cockroaches? What do they do? Cockroaches are reasonably abundant in the world. They seem to like living with human beings, right? So it's always a problem for people who don't keep their residences very clean or whatever, or sometimes even if you keep it clean, they're still around, right? Cockroaches. So the thing is this: cockroaches, first of all, they serve as prey for other species of animals or insects. uh, I've seen cats hunting cockroaches and eating them with great relish. Meow meow. Yeah, cats like cockroaches apparently. And other species of maybe birds, etc., would also prey on cockroaches and eat them. So the cockroaches are a good source of nutrition for many other species of rodents, of mammals, cats, birds, etc. They're a good source of nutrition, a good source of protein for these species. Secondly, cockroaches, they what they do is they eat organic material, and they accelerate the decomposition process of this organic material. So when there is a piece of food, let's say a piece of bread lying on the floor or somewhere else, cockroaches would go and eat that and decompose it rapidly to simpler organic material that can then go back into the earth and enrich the fertility of the soil and all that. So these are the kind of roles that an insect like a cockroach would play. And I'm sure they also prey on other smaller insects. So they serve as prey, and they also serve as predators. So there's always this sort of balance, big fish eating small fish, that sort of thing. So I am not an expert in cockroaches, but that's the general answer I can give you. This applies to all species of insects, animals, birds, fish, etc. on the planet. They serve multiple purposes. And what if cockroaches went extinct? So if you were to suddenly snap your fingers and make them all extinct, there would be a sudden imbalance in the ecosystem, and that would persist for, I don't know, years, decades possibly. When the role they were fulfilling, cockroaches were fulfilling in the ecosystem, suddenly disappears. There's a big hole, and then the ecosystem would have to rebalance itself. And yeah, there would be some consequences. Maybe there will be an explosion of certain kind of insect species that were being preyed upon by cockroaches, and maybe there will be an extinction possibly of certain animal species or insect species that primarily depended on cockroaches for food. So there could be that sort of imbalance. Yeah. So I think all species have their own significance and importance in the overall ecosystem of the earth. And if you make any species extinct, there's gonna be a certain imbalance. Yeah. So in evolution, species go extinct all the time, new species emerge all the time, but it happens over long time periods. So there is no sudden impact on the environment. But if cockroaches were to go extinct one day, like you say, that would cause a, an inequilibrium, in the environment, and that would be problematic. So that could cause such consequences like I just mentioned. So that, in brief, is about cockroaches. Shaheen Wahman Zadegan says, "What is ball lightning?" Yeah, it's a very poorly understood phenomenon, ball lightning. So this, some people say it's superstition or something, but it's definitely not so. Uh, People have reported these phenomena for centuries, for millennia, and recently they have even been caught on CCTV camera, etc. So what is this? It's a ball of light. Maybe it's a ball of glowing gas, possibly, or maybe it's an electrical phenomenon. It's typically 10 to 20 centimeters in diameter, maybe somewhat, sometimes it's larger in even rarer cases, and it glows, it pulsates, and it wanders around at approximately human head height. Yeah, not always, but sometimes. And it wanders around at walking pace, and sometimes it disappears in an explosive discharge, sometimes it just fizzles out. So let's take a look at what this actually looks like. Let me try and put that on the screen. Ball lightning. Let's see what that looks like. I'm sure there are images of that available. Let's look at ball lightning. Let's do a Google search. So what does ball lightning look like? Let's see some. So these are certain, they've taken, I mean, some of these phenomena have been captured essentially on CCTV, mostly on CCTV cameras. It's not always ball like, but this one here, as you can see, looks like a ball. There you are. Something that looks like this. Sometimes it's high in the sky, sometimes it's a lightning strike that creates this ball like thing. Yeah, there's another example. So this is typically what ball lightning looks like. It comes in various shapes and sizes, in various colors. Sometimes it's reddish, sometimes it's yellowish, sometimes it's bluish. Those seem to be the most common colors for ball lightning. And yeah, it's not very well understood. It certainly is something that exists. It's not a myth. Yeah, it's been captured multiple times on CCTV cameras, but it seems to be an extremely rare phenomenon. And when something is so rare, it's really difficult to replicate that. And as an experimental physicist, so if you don't know how something happens, you don't know how to replicate it. And if you don't know how to replicate it, you don't quite get to understand or figure out what is the physics behind that, right? What causes this phenomenon? So that is the reason why this phenomenon is extremely poorly understood. It's not been replicated, as far as I know, in any lab. And there are various hypotheses as to why this happens. Maybe it's a glowing discharge of electricity of some kind, or maybe it is a glowing gas that sometimes what happens is in marshy environments you have natural emission of gases from decomposition of various organic substances underwater, and you have the emission of gases like methane, etc. And these are flammable gases. So sometimes it could happen that causes this sort of phenomenon. Possibly that's one hypothesis, that's one theory. And there could be electromagnetic effects also possibly behind this. So we don't quite sure. But that, in brief, is what ball lightning is. It's a very poorly understood phenomenon, but it's a phenomenon that definitely does happen. Swapnil says, what caused the planets in the solar system to orbit the sun in an anti-clockwise manner and not clockwise? How would the Earth have been different if its revolution around the sun, was clockwise? Look, what do we mean by clockwise or anti-clockwise? It all depends on where we are. If I have a clock here in front of my face over here, yeah, It's going in a clockwise fashion. But if I was on the other side, it would seem to go in an anti-clockwise fashion, right? So when you have a stellar system with a star and planets, typically all the planets revolve in a certain direction. If you see it from one orientation, they will seem to be clockwise. If you see it from the other orientation, from the other side of the disk, they will seem to be anti-clockwise. So whether it's clockwise or anti-clockwise depends on where you are looking at the place, the thing from. That's it. That's what it is, right? So there's no way of saying what is the orientation. Is it clockwise? Is it anti-clockwise? It doesn't matter. If you see it from above, let's say above, if there is no up or down in space, first of all. So if so let me show you what a stellar disk looks like. One second. Let's see what this is. So let me put that on the screen. Here we are. So the solar system formed for something that looks like this: a protostellar or protoplanetary disk. So this happened. So where did all this gas come from? This gas that eventually formed the sun and the planets, it came from the death of a previous star, a star that existed in this region previously. And it most likely went supernova. It exploded in the end stage of its life, and the gas was present, and eventually it again coalesced. There are various star forming regions in various galaxies where you have a lot of gas, and that accretes together and eventually forms this sort of thing. So the thing about gravity is that when you have a gravitating mass of, let's say, gas, it will have a center of gravity where that's the center of gravity, right? At the very center of this object or this region. And when you have a center of gravity, all the other particles of gas and dust and whatever else will be attracted towards that. But the velocities will be such that the direction of the motion of these gas molecules, etc., will not be directly towards the center of gravity of the mass. And that is what causes the rotational motion, right? The entire protoplanetary or protostellar disk will have a rotational motion, and that is what gives rise to the fact that planets orbit around their parent star, and that is also what causes the rotation of planets. So that is what happens, and the planets will orbit around the sun or the star. And if you look at it from one direction, they will seem to be doing it clockwise. If you see it from the other direction, they will seem to be doing it anti-clockwise. So I don't know whether the earth is orbiting the sun clockwise or anti-clockwise. It is doing it both ways depending on where you're looking. So that is the answer. Okay, RTK says, why is there such a huge difference between humans and the species closest to humans? What led to the rapid increment of the personality of Homo sapiens? Well, I can certainly agree that Homo sapiens has a wonderful personality. We all have incredibly great personalities. I mean, look at our closest relatives: chimpanzees, gorillas, langurs, orangutans. Their personalities aren't that great compared to ours. I mean, we can do things that they can't. But on the other hand, they can do things that we can't. The only difference between us and them essentially is the level of intelligence. We have gone way beyond them. But if you look at the DNA, then the difference in DNA between me and a chimpanzee, let's say, would be about 1% or maximum 2%, somewhere between 1 and 2%. So the difference in the genetics is actually quite minimal. And yet it is that 1 or 2% difference in the genetics, in the genetic code, that makes us so different, right? But are we really that different from our closest relatives, the chimpanzees, the gorillas, orangutans, and the bonobos, etc.? We morphologically we are quite similar. We are not as powerfully built or physically strong as them. We are quite weak and puny, but morphologically we are very similar to monkeys, apes especially. Yes. uh, so I would not quite know if we have such a huge difference between us and them. Even if you look at various other species or families of species, let's say you look at the cats. You have your regular standard issue house cat, the domestic cat that lives with humans. And then you have other species of cats. You have the caracal, you have the lynx, you have the puma, and then you have larger cats like the jaguar or the leopard or the cheetah or the lion or the tiger and so on. And you have various other extinct species of cats like the saber-toothed tiger and all that. I'm sure there is a significant amount of 1 or 2% like difference in the genetic code in all these various species of cats. And yet they have so much difference morphologically, physically, especially from the size perspective. They look quite similar. If you were to take a standard issue house cat and magnify it by a factor of 10, it would look very similar to a tiger. It's built and designed the same way. It's just that there are certain genetic changes that have caused its size to be what it is. So it's all because of the game of evolution. Species diverge from time to time. So the last divergence between us and our closest relative, the chimpanzee, happened about 2 million years before today. That's 20. What is 2 million? That's 20 lakh, right? 20 lakh in Indian terms. Yeah. So about 2 million years ago, our species diverged from that of the our closest relatives, the chimpanzees, and because of various reasons. We're not quite sure what the reasons are. Maybe the formation of the Rift Valley, people have postulated that could be the reason. Maybe two population groups became isolated from each other because of various reasons, and they never were able to intermingle for like more than 1 million years, and that's why the divergence of species happened. And then when you are living in different environments, you evolve differently. So that is how it happens. That is how the divergence of species happens. About 6 or so million years before today, the common ancestor of humans and chimpanzees diverged from the common ancestor of humans, chimpanzees, and gorillas. And even then, there is a great deal of similarity between us humans and our gorilla relatives. They're also quite similar to us in a variety of ways. They are like massively muscular versions of humans, right? And so on. But they look quite similar to us in a variety of ways. So it is all because of uh, evolution. You live in different environments, you're going to evolve differently. You have to adapt to the environment. And it's sometimes uh, a question of random mutations that happen in DNA, but only those that are beneficial survive long term because of natural selection and so on. So that is what happened. That is how it happens. I would not say that there was a rapid increment in the personality of Homo sapiens. I am sure that our magnificent personalities developed over about 2 million years. And in the future, maybe we will be even better. But right now, I think our personalities are reasonably good. Yeah. Okay, Shubha says, is the metaverse really going to be developed further, or is it a concept with a lot of loopholes? We just spoke about evolution. Evolution happens in technology as well, in business as well. Technology evolves because of financial considerations, especially in a capitalist world such as the world we live in, right? So, corporations develop technology with the singular purpose of enriching themselves. They want to make money. They want to make their shareholders money, and they want to make their essentially the shareholders, right? The shareholders are the people who own stakes in the company, shares of the company. And the more the company makes money, the more the richer the shareholders become. So that is the primary purpose. And how do you do that? How do you make your shareholders rich? By providing a certain kind of value to the public. The public needs something or wants something or has a certain problem, and you provide solutions to that, and then the public will give you money in return for that. That's how you make money in any business. And sometimes you create solutions to problems that don't exist, or maybe sometimes you create things that addict your customers or hook them into this dopamine release cycle, right? You hook them to pleasurable things. Drug dealers do that. They sell drugs to their customers, and the customers get hooked to that. They get addicted, and they need more and more of that, and you can charge a lot of money for such drugs. Similarly, certain technologies could be like that. I'm not saying all are like that, but some could be like that. So what is this metaverse? The metaverse is going to be, it's kind of somewhat here, but not quite. In the future, what you're going to have is all surfaces will be uh, all surfaces around you, let's say walls, would be like laptop screens. You'd be able to watch a movie on your wall on demand, and there would be elements of augmented reality. You wear glasses, and through those glasses you will see metadata all around you. So you're walking on the street wearing glasses, and every single person that comes in front of you, you will see certain data for that person. This person's name is this, born on so and so date, this is their financial value right now, and so on and so forth, depending on the level of access that you have. So if you are a government agent working for the government with a certain level of clearance, you will see their entire life history displayed in brief, and that could help you identify suspects or whatever. Similarly, you could play virtual real or augmented reality games like the Pikachu thing that was a big craze. It's going to be taken to the next level eventually. So right now what's happening is that the virtual reality headsets or augmented reality headsets are quite bulky, right? In the future, the technology will be developed further, maybe in the next 5 to 10 years maximum, and you will have your regular glasses that will give you the same effect. In the future, you may not even need glasses, you may have contact lenses that would do the same thing. And further down the line, you'll have brain implants that will give you pleasure on demand, or augmented reality on demand, and so on and so forth. So that is the metaverse. It's going to add layers of reality on top of the actual reality we live in, right? And the hope for these companies, see, these are all American companies that are doing this. Yeah, they hope that the entire world will be hooked into this. They wish to create entirely virtual worlds and universes for people to inhabit. um, you already have such environments. There's this game called Roblox. It's a platform on which there are like a billion plus users, mostly kids, teenagers, and even younger kids who spend hours every day playing the game. And there are various other environments as well. The hope is that you will be able to bring these into the real world and merge the two things. So virtual reality and actual reality will be merged, and it will also have some actual benefits, like you'll be able to learn things faster. You may be able to sit at home and yet be in school, or sit at home in your bedroom and actually be at the same time in your office in the company of your colleagues, and so on and so forth. This is going to happen. There is a significant, massive push, to make this a reality, and there's a lot of money in that. If you are a company that offers your customers this sort of thing, then yeah, you're going to make a lot of money for sure. And that's why Facebook has renamed itself to Meta. And so it's a bunch of American companies, Silicon Valley based companies, that are trying to change the entire reality that we all live in, right? And it's going to end up benefiting them, it's going to end up benefiting their customers. And the demographic they are targeting is the youngsters, the Generation Z, the Zoomers, and even younger kids. That's whom they want to hook into this. So, because in 10 years, Gen Z kids will be young adults. And if you have hooked them into this at a young age, then they will be your lifelong customers. And there's a lot of money you can make out of each of them. So that's the kind of thing it is. Uh, I don't know what loopholes it has, but yes, there are drawbacks. Uh, it is not all going to be great for us. You could have kids sitting on a mattress in a dark bedroom, no lights, and they're wearing a headset, augmented reality or virtual reality headset, and they imagine they are superheroes and they're doing conquering the world and all that. In reality, they are sitting in a dark corner of a dark room on a mattress with no physical activity, just hooked into this virtual pleasurable universe, and it's not good for anybody for this sort of thing to happen. But yes, that is something that we are going down that alley right now. It's not all good for us. Technology is always a double-edged sword. You can use it for good, you can use it for bad. You can use fire to do good things, you can use fire to do bad things. You can use sticks and stones to do good things and bad things. You can use nuclear power to do good things for humanity, and you can also destroy humanity with it. Similarly, all these technologies also have dual use, multiple uses. And generally, if you want to make a lot of money, you sometimes lead people down the wrong road, and that's how it works. Yeah. So that is the deal with the metaverse. I'm not sure it's all good for humanity, and it could also end up transgressing on national security, national borders, all that, because the internet doesn't know any borders. Yeah. And so if you are a company that essentially is the platform for the whole world, you can set the rules and you can disregard the laws and norms that are in place in various countries. You decide what it's going to be like, and everybody has to obey you. So these are problems that are going to emerge, and the the nations that control this technology are going to essentially rule the world. So that is the crossroads that we are at right now. That is what the metaverse is. It's not one thing. You can In the past they used the term cyberspace. Today we have replaced that with the term metaverse. It's essentially the same thing. It is essentially the same thing. It's just the next level of cyberspace, more and more immersive. Then you will have metaverse 2.0, 3.0, maybe by 2050 or something, in which you will be completely immersed in these virtual environments. So that is what the metaverse is. Okay, I'm not sure what the name is. I can't read that, but the question is: the Potsdam Institute for Climate Impact Research, in a recent study, suggested that the combined effects of natural and man-made emissions-based global warming can delay the next ice age by 100,000 years, whereas other celestial phenomena, change in orbit, axial tilt, precession, etc., will continue as before. Obviously, the average interstitial glacial period is about 10 to 11,000 years, and we are nearing the end of this period. What will be the possible changes that the Earth encounters next? Okay, good question. So there are a number of factors uh, that cause the cycle of ice ages. You have, like you said, the change. It's not the change in orbit; it's the eccentricity of the orbit, which kind of changes over time. Yeah, it's a cyclical thing. Then you have the axial tilt. That also changes. The axis of the rotation of the Earth is tilted compared to the plane of the solar system. There's a tilt, and this tilt also changes. That takes several thousand years. The axial tilt, and then you have the rate of precession. So the precession happens, and there also has an effect on the climate of the Earth. So if you take these various factors into account, you have what is called the Milkanovich cycles. So there was this scientist called Milkanovich. That's the name I remember. I don't know the first name. So I think it was a he. So he calculated that I think it was 41,000 years. So according to his calculations, there should be an ice age every 41,000 years, or the cycle should last 41,000 years. And that apparently indeed was detected to be correct. But then there was a problem of the 100,000 year cycle, like you were mentioning here. So that is the 100,000 year issue or problem or something they call it. So instead of 41,000 years, it's a cycle of about 100,000 years. And like you mentioned, the interstitial glacial period means the time period between ice ages is about 10 to 11 to 12,000 years, and we are nearing the end of that, which means that maybe in a few centuries, maybe in 1,000 or 2,000 years, we could be entering a new ice age, or we should be about to enter a new ice age. And yet now we have this issue of global warming. Yes, and that's what the question is about. So I have not seen this study that you're mentioning, but we certainly know that there is this issue of man-made emissions, the carbon that is being released into the atmosphere, into the environment, right? And that is at, I believe, a significant high right now, and that is causing the greenhouse effect, the global warming. And by the end of the century, it is believed that the average temperatures on the planet will rise by about 2 degrees, maybe 3 degrees. I hope not 3, but definitely 2 degrees, which is a significant increase, right? So what is going to be the effect of that on the global 100,000 years cycle? um, we don't quite know. See, the climate is a very complex thing. There are maybe millions of parameters that go into creating the weather that we are experiencing right now. Millions of parameters. And you, no matter how powerful your supercomputer is, you cannot factor in all of these parameters. So, like you said, you have the major parameters like the orbit, the eccentricity of the orbit, the axial tilt, the precession of the equinoxes, those things, that is there. Then you have the greenhouse gas emissions that are going to warm the planet by about 2 degrees by the end of the century. So, typically, an ice age, I believe, decreases the overall average temperature of the planet by between 7 to 10 degrees. So if the average temperature, say, don't quote me on that, I may be somewhat off, yeah, but it decreases the temperature significantly. That's why you have ice sheets all across the world. So if the average temperature were to hypothetically, for the sake of the argument, drop by 10 degrees, but you have this warming which is caused by human by 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 man-made emissions, which will increase the temperature by 2, then a simplistic approach to this would be that you would have a decrease in temperature not by 10 degrees but by 8 degrees. So the ice age would still occur, but maybe it would not be that severe as it would otherwise have been. So there have been certain disruptive uh, phenomena in the past uh, that would otherwise not happen. For instance, the last time something strange happened was the something catastrophic happened was the Chicxulub impact, which happened 66 million years ago, which was a very massive impact which killed off the non-avian dinosaurs. It led to a condition similar to a nuclear winter. For about a decade or so, there was no sunlight. So it was not a greenhouse thing, it was the opposite of that. So we're not sure if it had any long-term consequences on the climate of the planet. I don't think there are any leftover effects of that catastrophe on the climate today. So that was obviously 66 million years ago, but over a period of a million or 2 million years, there would definitely have been a significant cooling of the Earth, even after sunlight reappeared on the planet. So, so there'll definitely be some impact, but we are not quite sure. I don't think any scientist has been able to predict exactly what the effect of man-made global man-made emissions and the global warming is going to be like. If the ice age is due to happen, it will certainly happen. Maybe it will not be as severe as it would otherwise have been, but it would still happen. So the 2 degrees rise in temperature would not be able to completely offset the 10 degrees decrease in temperature that would be the result of an ice age. So maybe the ice age would be somewhat milder, but it would still be there as far as I understand. So that's how I see things going. Swarup says, if light has no mass, why is it affected by black holes? Lage Raho Online says, Kimcho, Kimcho. Do light rays, radio waves, X-rays, etc., kinds of waves weigh? Do they have weight? Do they have mass? And what type of substance are they made of? Uh, so light rays, light waves, whatever, X-rays, radios, these are all electromagnetic radiation. So what are they made of? They're made of pure energy. A light ray, let's say we call it a light ray, or a radio wave, or an X-ray, whatever you call it, these are nothing but photons. Photons are packets or bundles of pure energy that have a certain frequency and a certain wavelength. The frequency is one upon the wavelength is one upon the frequency. So they're not made up of any substance, they're made up of pure energy. Initially, the universe was just pure energy. At the moment of the so-called Big Bang, it was all the mass and energy of the entire universe compressed into a single point, a singularity. So it was all pure energy, and then eventually, the space-time expanded, and things happened like things happen, and that gave rise to all the mass that we see today because of the various things that happen later on. So X-rays, light rays, radio waves, gamma rays, all these things, they are just electromagnetic radiation. It's pure energy. It has a certain wavelength and a certain frequency. Now, the other question is, if light has no mass, why is it affected by black holes? I think I've answered this more than once, but let's take it again. So light doesn't have mass. Light has energy. But we now know, because of Albert Einstein, who first showed us this, that energy and mass are interchangeable. Energy is equivalent to a certain amount of mass, and mass is equivalent to a certain amount of energy. And it's the most famous equation, most likely in physics: E equals mc squared. E is the energy, mc squared, m is mass, and c is the speed of light. So energy is equal to m mass times the square of the speed of light. That's how you uh, translate energy into mass and mass into energy. Equivalence. So light has energy. The equation for the energy of a photon is E equals h nu or hf, where h is the frequency of the light. So depending on that, and h is the Planck constant. So that's why, even though a photon doesn't have mass, it has an equivalent mass, or an inertial mass, so to say, or a relativistic mass. You can you can give it any name you want, inertial mass or relativistic mass, but it does have an equivalent mass to its energy. Now, why is light affected by black holes? Well, from the perspective of general relativity, we live in a four-dimensional space-time, right? And mass, the presence of mass in space-time, has the effect of curving the four-dimensional fabric of space-time. So it's the good old trope, right? You have a flat surface, a trampoline kind of surface. You put a ball in that, and it curves the surface, right? That sort of thing. So space-time is curved, not only the dimension of space, but also the fourth dimension of time. It's curved by the presence of mass. Mass tells space-time how to curve, and the curvature of space-time tells mass how to move, right? And since space-time gets curved, light is not able to travel in straight lines, and that's why it travels in a curved path. And that is why light is affected not just by black holes, but by any kind of mass. So that is one way of looking at it. The other way of looking at it is that light, even though it has only energy, it has an equivalent mass, and that's why it is affected by black holes and other massive objects. That's another way of looking at it. It's just analogies that I'm giving you, but I hope that helps you understand why this phenomenon happens. Polomi says, could you please tell us, why do fireflies glow in the night? And if they fly the whole night around, when do they sleep? Do insects sleep? Why do fireflies glow in the night? You know what? Fireflies can glow in the day as well, but you don't see it. So this is called bioluminescence. Uh, Fireflies have a certain enzyme in their abdomens. I think it's called luciferase or something like that. And when this enzyme reacts with oxygen, it produces light, and it's cold light. So when you have a light bulb, in order to emit light, it also has to become hot. So that is hot light. Any light bulb will become hot when it glows. Similarly, if you heat a piece of metal, it will glow, but it will also emit a lot of heat. In the case of fireflies, this reaction that happens, this bioluminescent reaction, is cold light. So it does not release any heat. If it were to do that, it would kill the fireflies. So it is a chemical reaction. This enzyme that reacts with oxygen causes the glow to happen. And the fireflies can control the glow, when it starts, when it stops. And typically they do it in pulses, you know. And if you see a whole forest full of fireflies, you will find that they're blinking in unison, in synchronicity. Yeah. So that's what you observe. That's a whole different phenomenon. So why do fireflies glow? Because they glow because of a phenomenon called bioluminescence. I think it's a enzyme called luciferase, if I'm not mistaken, that is behind this. Fireflies don't have lungs; they don't breathe, but they do absorb oxygen through a variety of means, and they can control this entire process, which is why they're able to control the way they glow. So they glow in pulses, on off, on off, on off. Now, do fireflies fly the whole night? I don't think they fly the whole night. Typically, they're sitting on branches and leaves and all that, and they're glowing and doing things. What is the purpose of the glow? I'm not sure what the purpose is. Maybe it is to attract their mates. Maybe it is to communicate with each other. Maybe it's to warn away predators, saying that I am not good to eat. This enzyme which glows is not doesn't have a good taste, and it will upset your digestive system or something like that. So we're not quite sure why they glow, but they do glow. I don't think they fly the whole night. In my experience, they sit on branches and leaves, and they sit and blink. That's what they do. Do insects sleep? Insects do sleep. uh, Insects have a central nervous system, and it is something that we observe in all animals that have a central nervous system, that they need sleep, right? uh, so it is a property that seems to be inherent to all creatures that have a central nervous system, a brain, and a nervous network, a network of nerves and neurons and all that is present throughout the body. But typically you need to have a brain. A brain is essentially a biological neural network. So any animal that has this sort of central nervous system is observed to sleep. Sleep has been observed in flies. You can see that if a fly is sleeping, their response to external stimuli is delayed. It is slow. If you deprive flies of sleep, then they need to catch up on more sleep, just like human beings. So yes, insects do sleep, not just fireflies, but I think all insects need a period of sleep, per their whatever circadian cycle they have, which is the typical 24-hour cycle that all humans and other animals that we observe, they have such a cycle. So yes, insects do indeed sleep. Anita asks three questions. Can nukes help us fight an alien invasion? Is it true that DRDO has more non-scientific employees than scientific ones? And why is there no factorial of negative numbers? All right, let's see this. Can nukes help us fight against an alien invasion? I think that if aliens have the technology to traverse interstellar space many light years and reach the Earth, if they have that sort of technology, which is way more advanced than anything we have, then I don't think nuclear weapons are going to be a big deal for them. Uh, so I am a little skeptical. First of all, we don't know if aliens exist. We have never found any evidence thus far. Maybe it's because we are too primitive and our detection mechanism is not good enough. But if aliens do exist, and if they're able to come all the way here and try to invade us, then it means that their technology is way, way, way more advanced than anything we can imagine. And if it is that advanced, then I don't think nuclear weapons are going to make a big dent on their efforts to invade us, like you say, invasion. So it's like, a fly or a mosquito trying to bite you, you can just swat it off, that sort of thing. It may have that sort of effect for aliens. So if aliens can come here and try to invade us, I am a little skeptical if nuclear weapons could deter them or defeat them. Yeah. Okay, is it true that DRDO has more non-scientific employees than scientific ones? As far as I know, DRDO has roughly 30,000 employees on its payroll, and about 5,000 of these employees are scientific staff, scientists or engineers, which means that about 25,000 of the 30,000 employees are non-scientific staff. I don't know what function, what purpose they serve, what function they perform, but it looks like a colossal waste of money, a massively colossal waste of money. Let me see if I can find something online. Let me see. Okay. What do we have? All right. I have a Wikipedia source. As always, please be informed, please be warned that Wikipedia is not necessarily a reliable source. I'm just putting it for the sake of convenience and brevity. I'm sure there are sources here. So if you see this, it says that it has 30,000 employees, out of which 5,000 are scientists. And it gives some reference. Let's take a look at the reference if you're able to open it. Maybe it's not openable. Let us see. So yeah, it does look like it has only 5,000 scientific employees out of a sum total of 30,000 employees. So just imagine the kind of salaries you're paying. 30,000, 25,000 non-scientist employees. You have to pay their salaries because they are government employees. You also have to pay their pensions whenever they get retirement and all that. It's a colossal waste of resources, in my opinion. The document did not open. Maybe we'll take a look at it other time, some other time, or maybe you can do some of your own research about this. But yes, it is indeed the case that uh, there are way more non-scientific employees in DRDO than scientists. Why is there no factorial of negative numbers? So how do you define a factorial? Let's say you have 5, the number 5. The factorial of number 5 is defined as 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 all the way to 1. It's 5 times 4 times 3 times 2 times 1. The factorial of 10 is 10 times 10 minus 1, 10 minus 2, and all the way up to 1. Right? So that is the way factorials are defined. There is no definition of the factorial for negative numbers. Because if you try to do the same thing for a negative number, let's say you want to do minus 3 factorial, then you would have to do minus 3 minus 1 times minus 3 minus 2, and so it would go all the way to minus infinity. So it's not something that is definable or defined for negative numbers. Factorial essentially is a way of arranging things. Let's say you got 5 different cards or 5 different chairs. In how many different ways can you arrange them? That is the meaning of factorial. Yeah. So in the case of negative numbers, there is no way of arranging negative numbers because negative numbers are actually in the real world unphysical, or they are something that only exists in mathematics, not in the real world, because there is no minus 1 in the real world, right? So these are the reasons why there is the factorial for negative numbers is not defined. So that's what I could explain, or I can explain. Aditya Ranjan Sahu says, please throw light on the super Kamikaode project and its purpose, working, etc. When will India start investing amounts into particle accelerators, joint ventures like LHC, etc.? Okay, let's talk about Super Kamikaode. The Super Kamikaode detector is a neutrino detector. It is in Japan. It is located deep underground in a disused mine of sorts. So let me show you what it looks like. I'm sure we can find an image of Super Kamikaode. All right, let me put that on the screen and show you this thing in all its glory. Give me a second. Let us place that on the screen. So this is what the detector looks like from inside. These bright things that you see are called photo multiplier tubes, and the detector is filled with ultra pure water, which means that it's going to be filled with water that has almost no impurities whatsoever. The water that we regularly use and drink and all that is full of impurities, dissolved minerals, salts, other chemicals, other things as well, in very small quantities, but it's all still there. I mean, when you drink mineral water, it has minerals dissolved into it. So this water that is used in this detector is ultra pure water, almost 100% purity. And like I said, all these bright things are um, photo multiplier tubes. So what happens? What are neutrinos? Neutrinos are fundamental particles that are emitted by the sun. Every single second, trillions of solar neutrinos are passing through my body every single second, and through your bodies as well. The sun gives off incredible amounts of solar neutrinos per second. Neutrinos have incredibly small masses. They it was believed for the longest time that neutrinos are massless, but now it is known that neutrinos have incredibly small masses, close to zero, very close to zero. So the sun emits through its nuclear reactions trillions, incredible amounts of solar neutrinos, and trillions of them pass through our bodies every second. Now, neutrinos interact weakly. They interact only through the weak nuclear force, which is incredibly weak. So a neutrino can pass through the Earth without interacting with a single atom inside the entire Earth. And trillions of such neutrinos pass through the Earth. So what this experiment does, what this apparatus does, is that it has ultra pure water in this tank, and the tank is surrounded by all these detectors. Yes, and we know that there are so many neutrinos passing through this water in this chamber, and every once in a while one of these neutrinos will interact with one of the molecules of the water in here, and the interaction is going to be such that it's going to produce a flash of light, and this flash of light is going to travel faster than the speed of light inside water, but slower than the speed of light in vacuum. And this gives rise to what is called the Cherenkov effect. And these photomultiplier tubes are going to, their purpose is to detect these flashes of light, which happen just once in a while, maybe once a day or so, even though there are so many neutrinos going through this detector. So that is what this apparatus does, and through the detections it is able to study the properties of neutrinos. So that is what this detector is, the Super Kamikaode detector, neutrino detector. And it can help us detect supernovas, because when a star explodes in a supernova explosion, it releases incredible amounts of neutrinos, and that can help us uh, understand supernovas better. So, and it can also help us detect where these supernovas are happening, and so on and so forth. So there are multiple reasons why this detector has been constructed, and that's what it is about. So the next question is, when will India start investing money into particle accelerators, joint ventures like LHC, etc.? I don't think that's going to happen. Uh, we have a couple of detectors somewhere or the other. In the TIFR in Mumbai, there is an ancient instrument called a pelletron, which accelerates, I believe, lead ions to a certain velocity and all that, and collides them with targets, and you can do some basic nuclear physics experiments with that. I think it's been around for decades. Yeah, this pelletron, I believe. And we may have some other instrumentation as well, but nothing cutting edge, nothing which would be considered to be the latest kind of thing. So particle accelerators cost a lot of money. It's a very advanced technology, and for instance, the Large Hadron Collider, I believe it cost billions of dollars, maybe around $10 billion, maybe more, roughly something like that. That's a lot of money, and it consumes an enormous amount of electricity in its operation. So I think the budget of the LHC was larger than the annual budget of many countries. So it's very expensive, and there is no point constructing a particle detector that is like underpowered, because you're not going to do any new physics with that. You're not going to make any new discoveries with that. So so there is no point as such right now of constructing super expensive particle accelerator in India right now, because whatever had to be done, whatever experimentation needed to be done to discover whatever we discovered thus far has already been done in other countries. So it would be like reinventing the wheel, and what's the purpose of that? Yeah. What is going to happen is that India is going to get its own LIGO. So LIGO is the gravitational wave detector that has done all the detection of gravitational waves thus far. When was the first gravitational wave detected? I think it was in 2015 or thereabouts. Yes. That was done by LIGO. So India is going to get one LIGO detector. It's going to be called Indigo or something. The project was approved several years ago. I don't know what is the status of the thing right now. You need a big piece of land on which you build the detector. It's a Michelson interferometer kind of design. It's each arm is several kilometers long. So what India will be getting is essentially the same detector as the two detectors in the US, and eventually, maybe in the next 5 years or so, 5 or 10 years or so, it will become operational. I don't know why it's taking so long, but yeah, that's how it is in India. Everything takes a lot of time. So that is one thing that's going to happen in India. That is the kind of experimental physics that will be done here, but apart from that, nothing else. That's how it is. Samarth says, how do wildfires begin? What is a wildfire season? Is it completely because of climate change? A wildfire is a forest fire, or a fire that takes place, that occurs in uninhabited land, typically a forest or a jungle, or grassland, savanna, that sort of thing. Yeah. How do wildfires begin, and what's a wildfire season? See, I believe that about most of the wildfires that begin are because of man-made causes. About 15 or 20% of wildfires would have natural causes. Maybe 80% of them, roughly, are initiated by man-made causes. Somebody is smoking and they dump their cigarette butt somewhere without extinguishing it properly. That may and that may cause a wildfire. Or somebody sets a small fire just for arson purposes. That could cause a wildfire. You have an electrical short circuit somewhere, that could trigger a fire in a forest, or what's called a wildfire. So most of these wildfires actually are caused by human beings. What are the natural causes of wildfires? So typically a wildfire, a forest fire, takes place in the dry season, when there is a drought or when there is a summer, the heat is high. That's typically when these fires occur. Fire needs three things. First of all, it needs fuel. So let's say dry grass, or a dry forest where there is very little moisture. So it needs fuel, firstly. Secondly, it needs oxygen. We have oxygen everywhere. And thirdly, it needs a spark, a temperature that ignites the fire. So typically, it is lightning that sets off natural wildfires. When you have a lightning strike on a tree, and if the tree is dry, then that naturally causes a fire, and then the fire can spread if the forest or this area is dry. So that is typically how wildfires begin, through natural causes. What is a wildfire season? Typically it's a summer season, or a season, a period of time when you have dry weather. There's no rainfall, so forests are dry, grassland is dry, and that makes it very conducive to start burning if there is a fire. If you have a forest that has recently had rainfall, even in such a forest, even though if there's a lightning strike, that fire will most likely not spread far. It may just burn down the tree, but the surrounding trees and grassland will not be affected much because they're all wet. When you have drought or dry season, that's when the fire can spread. So that is what a wildfire season is. It is a dry season, let's say in Australia. Yeah. So in recent years, in 2020, I believe 2021 as well, you had this massive spate of wildfire outbreaks, and it caused a lot of damage. Many animals died because of that. Many people lost their houses. You've had wildfires in Spain, in Europe as well. And I believe in 1998 or 88, was it, or 86? I'm not sure which year it was. There was this massive wildfire season in the Yellowstone National Park in the US. I think it was in the 1980s or 1990s, maybe 1990s. And a significant proportion of this national park was burned down in this outbreak of wildfires. And even a decade later, you could see the burned down trees. They were still strewn around. Yeah. So that's how it happens. And often what happens is that firefighters and national park wardens, etc., they are overzealous. in combating wildfires. Fires often happen, about 10-20% of fires happen due to natural causes, by lightning strikes and so on. Such fires should not be hindered. This is a natural phenomenon. Such fires should be allowed to go on and die off naturally. So when you allow that to happen, when you allow these small fires to progress and die natural deaths, that ensures that there are patches of forest land or dry land that are cleared out naturally. If you don't allow natural wildfires to die a natural death, then over time your forest becomes a ticking time bomb. And when a fire does happen, almost the entire forest will be burned down. So that's why sometimes these people, they get overzealous in combating and stopping wildfires. uh, so yeah, that's what it is it completely because of climate change? I don't think it's completely because of climate change, but yes, we have extreme weather nowadays. You have hotter summers in recent years, so that does contribute to a certain degree to the incidence of wildfires and the intensity and severity of the effect. Yeah. Okay, Karan says, what are cosmic rays and what is cosmic wind? Okay, cosmic rays are essentially fragments of atoms that come from space, from outer space, and they bombard the earth. Typically you have fragments of atoms, as in atomic nuclei. So what is the nucleus of a hydrogen atom? It's a proton. What's the nucleus of a helium atom? It's an alpha particle, and so on. So typically, and you also have electrons and all that. So cosmic rays are this bombardment of atomic fragments that happens from outer space. It hits our atmosphere, and it causes downstream effects. So typically when a cosmic ray hits the atmosphere, it interacts with the atoms in the atmosphere, the upper atmosphere, and a new kind of particle is created out of this. It's called pions. Yeah, pions are created, and pions decay into muons, and muons are what hit the earth, and they go deep into the earth's crust, into the earth's surface. So that is typically what cosmic rays are. Now cosmic rays come in a variety of energies. Most cosmic rays are reasonably low energy cosmic rays, like a small underpowered particle accelerator. But you also have these very energetic cosmic rays, ultra high energy cosmic rays, UHECRs, that are more that have more energy than anything the LHC can produce, for instance, right? Um, so yes, you have these cosmic rays once in a while, UHECRs, ultra high energy cosmic rays, that you find. Uh, I think in the 1990s, there was a cosmic ray detection that was called the Oh My God particle. It was, I believe, a proton or some such fragment of an atom, but the energy it carried was like a cricket ball traveling at around 60 kilometers or 100 kilometers per hour. That's the kind of energy a single atomic fragment was carrying. It was called the Oh My God particle. Yeah. So that's what cosmic rays are. It's a natural phenomenon. If you go higher into the atmosphere, you find a higher incidence. You find you're able to detect more and more ionized atmospheric particles and so on. Yeah. So I think these cosmic rays were detected in the 1910s or 1920s by a scientist, by a physicist, who went up into the atmosphere on a balloon and measured the amount of ionization of the air at higher altitudes, and that's when it was discovered that there is higher ionization as you go higher up into the atmosphere, and that was the discovery of cosmic rays. So that's what cosmic rays are. Now we are not quite sure of how they are produced. There are various possible mechanisms. One mechanism is that they are produced by supernova explosions, uh, active galactic nuclei. Various other mechanisms are also proposed. There are more exotic mechanisms that have been proposed, like the annihilation of dark matter particles, Hawking radiation, things like that. So we're not quite sure of exactly how cosmic rays are produced, especially the ultra high energy cosmic rays. But various mechanisms have been proposed, and some of them have been kind of corroborated. Like there is there seems to be definitely a supernova component to cosmic rays. So some cosmic rays are definitely produced by supernova explosions. But why do cosmic rays come in all the time? Most of the cosmic rays are deflected by the Earth's magnetic field, but some of them definitely hit the atmosphere, and the effect can be measured. Yeah. So that's what cosmic rays are. What is cosmic wind? It's it's the very thin, diffuse amount of dust and gas that you find in interstellar space. So let's say you're in a rocket or a spacecraft that is traveling across the stars in interstellar space. Space is vacuum, but it's not a perfect vacuum. There you will encounter some atoms of hydrogen and some other elements from time to time. It's a very, very, very thin and diffuse gas. But in some parts of the cosmos, you will have thicker dust clouds, thicker gas clouds, especially in star forming regions and so on, in nebulae, etc. So, all of this is what makes up cosmic wind. It's what you encounter as you travel through interstellar space. That is cosmic wind. Pawan says, please talk about the Permian extinction and how cynodonts were able to survive in those conditions. Is it true that we are successors of cynodonts? So you're talking about the Permian Triassic extinction event that happened roughly 250 million years before today, maybe 251 million years before today. You can look up the exact time period when this happened, but roughly 250 million years before today, 25 crore years before today. It was one of the most severe extinction events that we have uh, witnessed in the history of our planet. I think more than 60 or 70% of species, terrestrial species, went extinct, and maybe close to 90% of marine species may have gone extinct during this extinction event. So that's what the Permian Triassic extinction event was. What caused this? We're not quite sure of what caused it. It happened so long ago, and the evidence for this extinction event is found only in the fossil record. So you can see that lots of animals have died out, and the fossil record is found in sedimentary fashion, in sediments, and you can see, so each sediment that comes above the previous one is a subsequent time period. It represents a subsequent time period. You can see there is a sudden change in the fossil record. Lots of species that were found below have suddenly disappeared, which is the sign of an extinction event. So we know this happened because of the fossil record, but we are not quite sure why it happened. Typically, it's a combination of multiple factors. One of the factors that is possible is a massive supervolcanic explosion in Siberia, the Siberian traps, it was called. So that could have contributed to this extinction event. We also know that the oceans had become anoxic. What is anoxia? It means the oceans lost their dissolved oxygen. How do fish breathe? How do fish survive? They need oxygen. They need oxygen in their blood. So there is oxygen that is dissolved in the water of the oceans and rivers and ponds and lakes, etc., which the fish use for respiration through their gills. If the ocean becomes deprived of water, if the level of oxygen, sorry, if the level of oxygen that is dissolved in the water decreases beyond a certain level, you will have a massive dying out of marine life. First of all, the fish will die. If the fish die, then the animals that eat the fish will also die. So that will cause a cascading chain reaction. And if the anoxia is widespread, then it could cause an extinction event like the one we are talking about. So it is most likely known that the oceans had become anoxic in large parts, and water had also become acidic, apparently, because of various reasons. So you had a combination of factors. You had the anoxia in the oceans, you had acidification of the oceans, and you had the Siberian traps, super volcano explosion, eruption, which also contributed to this. So maybe it's a combination of these factors that caused the Permian Triassic extinction event about 250 million years before today. Now, you are asking me about cynodonts. Let me show you what cynodonts look like. So cynodonts were the ancestors of mammals. This is what cynodonts looked like. They lived during this period, and there were many species of these creatures, cynodonts, that looked kind of like dogs, kind of like rats. Yeah, that's what they looked like. They came in different sizes and shapes. And yes, so these were the ancestors of mammals. One of the lineages of these cynodonts survived, and that is why we are alive today. So these creatures, so these animals that you are seeing here are artistic recreations of what these creatures would have looked like. And these are our ancestors. So yes, all mammals that survive today are the descendants of one lineage of cynodonts that was able to survive the Triassic Permian extinction event. So how did cynodonts survive this? We don't know. Maybe it was a species of small cynodont that survived. If you're small, you don't need a lot of food. You don't need to consume large amounts of food if you are a small creature, and maybe that's why they were able to make it. Similarly, their descendants that survived uh, the Chicxulub impact event also survived, most likely because they were small. So there was this period of nuclear winter after the Chicxulub impact, and we know that our ancestors, the mammals of that time, survived. Maybe it's because they were small. And similarly, the avian dinosaurs also survived because they were small in size and they were able to survive on less food. So typically, if you are small in size, it actually kind of, in these adverse conditions, helps you to survive. Larger species of animals die out very easily because they need large amounts of food to survive. So that's how it works. So most likely, cynodonts, or the lineage of cynodonts that survived because of a small size. Okay, Karan says the ultramassive black hole TON 618 is 2,606 astronomical units in diameter, while our entire solar system is 80 astronomical units in diameter. The size of this black hole is mind boggling. How would such a large black hole form? Um, what is an astronomical unit? First of all, an astronomical unit is the distance between the sun and the earth. That distance, the average distance between the sun and the earth, is called 1 astronomical unit. So I'm not sure how large the diameter of the solar system is. The actual solar system, if you consider the Oort cloud and all that, extends to beyond 1 light year in diameter. But yeah, if you consider the main planets up to Neptune, maybe up to Pluto, maybe if you look at the other outer planet, minor planets, etc., maybe it's 80 astronomical units. And if we take that as the diameter of our solar system, then this supermassive black hole is monstrous and massive. Let's see what it looks like. So we don't have an actual image of the black hole, but we have these artistic representations of this thing. So yeah, you can see that it's quite large. Let's see a comparison, if you can find, between this thing and the sun. All right, so yeah, there you are. So it's an enormous black hole. The question is, how did this black hole become so large? So large. Okay, so how do black holes form? There are multiple mechanisms through which black holes are born. Uh, the most well-known mechanism is the death of a star. If a star is a certain size, maybe 20 solar masses or more, then it, at the end of its life, it goes supernova and there's an implosion, and the implosion the mass in the implosion that is falling inwards is so high that it collapses into a black hole, right? It is able to overcome the other forces that are trying to prevent the collapse, the Pauli exclusion principle and all that, and it collapses into a black hole. That is one mechanism of black hole formation. Now, what we know is that most galaxies have a supermassive black hole at the center. Our own galaxy, the Milky Way, is known to have a supermassive black hole at its center, and most of the other galaxies that we know of have supermassive black holes at their centers. So it is one of the theories is that galaxies formed in the early universe around black hole seeds, black holes that eventually became supermassive black holes. And maybe these supermassive black holes originated as primordial microscopic black holes. So in the very early universe, it is possible that an incredible amount of microscopic black holes were formed because of quantum fluctuations and because of the incredible densities that we had in energy densities that we had in the early epoch of the universe. So you would have regions of over densities that would collapse into black holes, and these are the primordial black holes. We have never detected any, but according to the laws of physics, it is quite likely that enormous amounts of primordial black holes may have formed. So when you talk about a black hole this large, incredibly large, larger than the solar system itself, most likely such black holes would form from the merger of multiple smaller black holes. So the merger of a black hole is like, you could consider the analogy of two water drops merging, that sort of thing. Yeah. So a black hole this large, we don't quite know how it is formed, but most likely I would imagine it would have emerged out of multiple mergers of multiple supermassive black holes. And that would have happened in, I don't know, in the past 13.8 billion years somewhere. So what are the exact circumstances that led to its formation? We still don't know. And maybe we may never know, because it's, I don't know how far away it is from here. But yeah, one of the scenarios is the merger of multiple black holes. Maybe it swallowed entire galaxies and the supermassive black holes that came with those galaxies. And that is one possibility. So we don't have the answers, but there are multiple scenarios that could lead to the formation of a black hole this size. Naga Sai says, how do living organisms know at what rate they should age? Time dilation, depending on the gravity, general relativity, or velocity, special relativity that they experience. Okay, so aging and general relativity or special relativity. See, listen, organisms don't know anything. Organisms age as part of a natural biological process. I am an organism. We are all organisms. If we would have our way, we would never age at all. Yeah. But it doesn't work like that. It's not a question of what we want and what we wish to do and what we know. It's just a biological process. Physics is not involved in this. Of course, it is quantum physics that gives rise to chemistry, and it is chemistry that gives rise to biology. So yeah, at the deepest level, it is quantum physics. Yeah, sure. But relativity doesn't seem to enter the picture. So there is no time dilation here. There is no special or general relativity involved in the aging process of animals and organisms. So how does aging happen? In the body, in any organism, you have cellular division. Yeah, cells divide, and that's how they reproduce, and that's how the body produces new cells. Now, most cells carry DNA. Our red blood cells don't have nuclei and they don't have DNA, but most other cells have DNA. And the DNA is found in the nucleus of cells in the form of chromosomes, right? Now, these chromosomes come in various sizes and shapes. X chromosomes, Y chromosomes. These are the These are the sex chromosomes, and then you have other chromosomes as well. There are 23 pairs of chromosomes in the human cell, as far as I remember. Yeah. Now, when cell division happens, the chromosomes also divide and they replicate. Each time cellular division happens, the ends of the chromosomes, which are called telomeres, become slightly shorter. Let's see what a telomere looks like. Let me put telomeres on the screen. So, telomeres are these structures at the ends of chromosomes. Every time cellular division takes place, the telomeres at the end of the chromosomes become slightly shorter. And as you grow older, as your body ages, there is more and more cellular division that takes place at a certain rate. And over time, the ends of your chromosomes, the telomeres, become shorter and shorter. So that seems to contribute to the process of aging. So, as you can see here, in a young organism, the telomeres are longer. In an older organism, the telomeres are shorter. And it is also believed that if you are able to prevent the shortening of the telomeres, then you may actually end up either slowing down or even stopping the process of aging. And that is where this all this research is being focused right now, on trying to stop the process of the shortening of telomeres. If you can do that, then you may be able to prevent aging, and you may have permanent youthful life. So that is still a work in progress. It's still far away, if it ever happens, but that is how the process of aging seems to happen. Yeah. So it doesn't have anything to do with time dilation or special relativity or general relativity. It's just biology, right? That is what is behind the process of aging. Okay, runtime says, can you explain about different constellations and their significance? What are constellations? Constellations are various arrangements of stars that we see in the night sky. So if you go out in the dark, people these days don't look at the sky. You go out into the open at night, where there is less light pollution, then you will be able to see lots of stars in the sky. And if you see the stars, we human beings are very good at perceiving shapes, even where there are no shapes. So in the old days, our ancestors would look at the stars, look at the sky, and they would imagine that the stars come in, the arrangements of stars is in various shapes, and they would give names to these shapes. One of the famous ones in Sanskrit is called the Saptarishi constellation. In English, it's called the Great Bear, or the Great or the Big Dipper, or whatever. So let's see what constellations look like. Where are the constellations? Here we are. So this is the Orion constellation. Orion's belt is there, right? It's the Hunter, and this is a sky chart with various constellations: Cassiopeia, Andromeda, Fornax, Sculptor, and so on and so forth. So these are the various constellations: Sagittarius, Scorpius, Libra, Serpens, the snake, Capricorn, the goat, and so on and so forth, right? So these are the various constellations. They are simply stars that we have imagined to be arranged in various shapes, and that's how we perceive it from here. If we were to go to a different star system, then we would see the star from a different perspective, and then you would have different constellations. You would not find the same constellations from a different star system. If you were to go to, let's say, Proxima Centauri and look at the sky from there, you would not see the same night sky as what we see from here on Earth. So it's all a question of your perspective, of where you are located, and you see a certain perspective from there, right? So that's what the constellations are. The various shapes that we have imagined that the stars are arranged in, and typically it's the brightest stars that we arrange in these shapes. I mean, that's how we imagine the shapes to be. That's what constellations are. We call them nakshatra in Sanskrit. What is their significance? There is no real significance. Of course, we find significance in everything. So there is this entire thing called astrology, the zodiacal signs, and The constellations are named after zodiac signs, or zodiac signs are the constellations, and it seems to have some relationship with astrology, not astronomy. And what that is, I don't know. I have no understanding or expertise in this particular field, astrology. So that's all I can tell you. uh, from my perspective, the only significance is that it looks like various shapes, and that's what we have imagined. There is no physical significance as such. From my perspective as a scientist, I don't understand astrology. Yeah, so that's what I can say. Long question. Rishabh says, do you think we are creating a prison and trapping ourselves unknowingly for future space missions? Our satellites stop working after a certain time. It just becomes a rogue, uncontrollable object orbiting the Earth. There are lots of satellites orbiting the Earth without any control. They're dead. If the number keeps increasing rapidly, then it will be impossible for humans in the future to send rockets to any other planet. If this becomes reality, then what will be the solution? It is becoming increasingly a problem, an issue that needs to be looked into seriously. It's not just dead satellites; it's also space junk, debris. You know, so that's becoming a problem. There is this entire cloud of space debris around the Earth. Let me see. Space debris. What does it look like? So this is a representation of the major such objects that are in orbit around the Earth. These are the major ones, but there are lots more such objects which are, centimeters in size, that can cause massive damage to a spacecraft or a rocket. They can even, puncture the walls of a space station and cause, well, catastrophic damage. So yeah, space debris is definitely a big problem. So is the problem of drifting boosters in space. Boosters typically re-enter the atmosphere quickly and burn up, or fall into space, or fall into oceans, or maybe somewhere else. But these dead satellites, etc., are, and especially space debris, the broken up space debris, is a big problem. And if we don't do something about it now, it's going to, like you said, trap us in a prison that we will be surface bound. We will not be able to safely launch rockets if there is so much debris, and that could prevent future space exploration. So that is certainly something that could happen in the future if we don't take steps to rectify the problem right now. So what steps can we take? The simplest action that we can take is that any satellite that is launched should have an expiry date, and it should have a mechanism that once the expiry date is reached, it re-enters the Earth atmosphere and burns up in the atmosphere. So you could provide it with a small rocket motor, rocket engine, or something, for just this purpose. That when it reaches a certain amount of time in space, it will be brought back into the atmosphere and allowed to burn up. You do that, it's going to solve the problem. But of course, a rocket motor, rocket engine costs money. It also adds extra weight to the bill that you have to pay when you launch your spacecraft. So yeah, most people, most nations, most companies, most corporations would try to cut down on that cost, right, and leave the problem for the future. So that is a problem. So I think there needs to be some kind of consensus among the spacefaring nations that this is the new standard or norm that we need to all follow. If we do that, then at least the spacecraft and satellites we are launching now and in the future will not contribute further to this problem, right? So yeah, that is the one solution I can think of, that ensure that every single satellite that is launched is allowed to remain in orbit for a certain specific number of years. You decide what the number of years is. You want it to be there for 5 years, great, it's your choice. You want it to be there for 20 years, your choice. But at the end of the time period, it is your responsibility that you bring it down and make it burn up in the atmosphere. So that sort of thing needs to be done. If we do that, then things will be fine. Aman says, Is there any evidence to suggest that the laws of physics remain constant in this universe as assumed by Sir Albert Einstein in the special theory of relativity? Um, all the evidence that we have tells us that the laws of physics seem to be the same no matter where we look. So, how do we know this? We know this through observational evidence. The laws of physics that apply to us over here on our home planet are the same laws of physics that apply anywhere else, that are in force anywhere else in the universe. Even if you have a galaxy that's 10 billion light years away from here, the same laws of physics are known to be in force there as well, because we are able to make observations through telescopes and with the various other instruments. And from all the evidence that we have gathered over all these past few decades or the past century and more, all of this evidence has not thrown up a single instance of any known law of physics being violated, right? So everything that we know about physics is true even there out in outer space. So thus far we have found no evidence that suggests that the laws of physics change in different directions, they are different far away from here. All right. So from all the evidence that we have, the laws of physics are the same everywhere thus far. Jasmine says, what is the definition of consciousness in your modern physics, if there is one, considering the fact that physics has rules and laws and theories for everything? There is no definition of consciousness in modern physics. Consciousness, we don't know what it is. We don't even have a definition for it, and that's why we are not able to discuss it or do research in it. Consciousness does seem to be a thing in physics. Uh, it may or may not have some kind of role to play in various interpretations of quantum mechanics. Yeah. So consciousness is of becoming increasingly important, especially in the frontiers of physics. Possibly, yeah. But we still don't have a definition of what consciousness is. Consciousness, as far as we understand, seems to be possibly a biological phenomenon. We know that we are conscious, but we don't know how to define what this consciousness is. Consciousness seems to be a combination of various characteristics. We are conscious. We know that animals are conscious. Our pet doggy or pet cat, they are conscious. Birds are conscious. When we see something that is conscious, we recognize that immediately. But we don't have a clear scientific definition of consciousness. We have various artistic definitions of consciousness, etc. But science is a rigorous thing. It's a rigorous practice, and we need very clear and precise definitions of phenomena if we want to actually examine those phenomena and in a scientific manner. And unfortunately, we don't have a definition of consciousness. The question is, what are the characteristics of a conscious system? Let's call it a system. Let's say I have a box in space, and let's say that box is conscious. What are the characteristics that it should exhibit in order to be conscious? Is there a consensus for that? We're talking about a box, not a human being. So, what is the difference between a conscious box and a conscious human being? What's the difference between a conscious computer, if such a thing would exist ever, and a conscious human being? We don't have any clear definition of what constitutes consciousness. Clearly, consciousness has something to do with memory. Without memory, there is no consciousness. To be conscious, you need to first be conscious that you exist. To be conscious of yourself, you need to have some memories of the past. So there seems to be some relationship with memory. So a system that is conscious needs to be able to store memory. To be able to store memory, it needs to have organs that capture information from the outside universe, right? So now we're talking about biological uh, aspects of that, because or maybe mechanical aspects. So we're not quite able to define clearly, precisely, and unambiguously what a conscious system is like, what are its characteristics, you know, sufficient, necessary and sufficient conditions for something to be conscious. So we don't have that as of today. And that's why it's well nigh impossible to have any meaningful discussion of consciousness in science as of today. Maybe in the future things will change. Keshav says, in one of the recent videos, you have said that the brain can be developed differently when you learn multiple languages. Is it about thinking abilities or actual physical changes that happen in the mind? Um, there seems to be a relationship between multilingualism, being multilingual, and the IQ score that you get when you do an IQ test. So people who are multilingual seem to have a somewhat higher intelligence quotient. Now, IQ is not necessarily a measure of your intelligence. Some people say it's a pseudo scientific swindle or whatever, but there seems to be a correlation between knowing more than one language and the amount of IQ points that you have more than the average. Yeah, that's one thing. Now, I'm not sure if anyone has done a study of multilingual people and what sort of brain structure they have. I'm not sure about that. But what we do know is that there was a study that was done um, in people who memorized large quantities of Sanskrit texts. So let me see if I have any of that here. I think it's called the Sanskrit effect, right? So there are these scholars, pandits, who memorize entire large Sanskrit texts. They memorize it precisely, not just the text itself, but the correct pronunciation and the way in which you're supposed to recite it and all that. And they do it for years and years and years. And what was discovered is that certain portions of their brain are more developed than others. Now, we don't know if it is only something to do with Sanskrit only or other languages also. If you memorize things, will it have the same effect? But thus far, it seems to be uh, isolated to only Sanskrit as far as we know. It's called the Sanskrit effect. Let me show you what this looks like. Um, Let me pull that up on the screen. Give me a second, please. There was this article in Scientific American. Yeah, it's called A Neuroscientist Explores the Sanskrit Effect. MRI scans show that memorizing ancient mantras increases the size of brain regions associated with cognitive function. And yeah, this article describes all of that. So these Vedic Sanskrit pandits that train for years to orally memorize and exactly recite very ancient texts, which have 40,000 to 100,000 words, right? They discovered that the structural MRI scanning was remarkable. Numerous regions in the brains of the pandits were dramatically larger than those of other people, with over 10% more gray matter across both cerebral hemispheres and substantial increases in cortical thicknesses, and so on and so forth. And more interestingly, for verbal memory, the Pandit's right hippocampus, a region of the brain that plays a vital role in short as well as long term memory, had more gray matter across nearly 75% of this subcortical structure, and so on and so forth. So, yes, the memorization of Sanskrit texts seems to alter the structure of your brain and thicken certain regions, and it's certainly something that is detectable in MRI scans. So yeah, that is what I can tell you about being multilingual, and whether that has any effect on the brain structure. I am not quite sure. Maybe you can do your own research and find out if any such study has been done, but this is what I know for sure. Okay, next question. Avinash says, if a distant solar system is millions of light years away, and so we see it as it was millions of years ago, how can we see what it looks like now? We can't. We cannot. In relativity, simultaneity itself doesn't exist. Whether two events happen simultaneously or not depends on where you are relative to these two events. If you are in a certain position, location in space time, the two events may appear to happen simultaneously from your perspective. But your friend who may be in certain other position in space time may see one event happen before the other. So this is called the simultaneity of relativity. This is something you learn when you study special relativity. So simultaneous events are not necessarily simultaneous. They are simultaneous only for certain people in certain places, for certain observers. Now, if you have a solar system that's a million light years away, you're seeing it right now through the telescope or whatever, you're seeing what happened there a million years ago. Let's say you receive a message from an alien civilization, yeah, and you try to figure out where it came from, and you see that it came from a system that is a million light years away. Then what happened actually is that those people who sent you that message sent that message a million years before today, right? So that's how it is. There is no such thing as right now. Right now happens only here. What is right now here is not right now there. Simultaneity itself is not quite a thing in physics, in special relativity. Yeah. So you can never see what it looks like right now. You can only see what it looked like then. That's just how it is. There is no way around this restriction, so to say. Yeah. Quotes says, what time is it at the poles, North Pole and South Pole? Okay, let's see what the poles look like, shall we? We're gonna bring in the map today in a science session. Sorry, not this one. Let me bring in something else. Let me bring in the map. Where's the map? Here's the map. Okay, poles. So on the top you have the North Pole. On the bottom you have the South Pole. Let's say you are standing at the North Pole, and you go 10 kilometers south, 10 kilometers west, and then again 10 kilometers north. You will end up again at the North Pole, right? So that's how it is. So no matter which direction you go in south, and if you do this procedure, you will end up at the North Pole. And similarly, the reverse happens at the South Pole. So the Earth has these longitudes which give us the time zones, but the thing is, at the poles all the longitudes converge, right? All the longitudes converge at the poles, which means that if you are at the poles, you can decide whatever time it is. It is all times at once. Time doesn't really have a meaning from the perspective of time zones at the poles. So let's say you are from India and you're working in Antarctica. You go to the South Pole, you can decide that it is Indian Standard Time over there. But your friend who is from Chile can say that it is the Chilean Standard Time over there. And another friend of yours who is from South Africa could say that it is South African Standard Time. So it doesn't matter. At the poles, you can interpret it as whatever time you want it to be, because all the longitudes converge at the poles. So all times are the same at the poles. Karan says, what are microbial black holes? Microbial black holes. So I have never heard of I've never heard of microbial black holes. I know about microscopic black holes. Microbes, which is microscopic organisms, are indeed microscopic, but they're not black holes. And black holes are not living organisms, right? So there is no such thing as a microbial black hole, but there are possibly microscopic black holes, MBH. And microscopic black holes could have been produced in incredible numbers, enormous quantities in the very early universe. during the reheating period, even before inflation, before the inflationary epoch, during the inflationary epoch as well, possibly. Yeah, an overproduction of microscopic black holes could have happened during these various phases of the very early history of our universe, because of quantum fluctuations, and these fluctuations creating regions, very small regions of overdensity that would collapse into a singularity, into a black hole, and that sort of thing. So these are the hypothetical microscopic black holes that we have never observed thus far, but they can exist. From the law, according to the laws of physics, such black holes can certainly be formed. So that is microscopic black holes. If they formed in the very early universe, they would also be called primordial black holes. So that's what it is. It's not microbial, but microscopic black holes. Okay, Down to Earth says the question is about poison. Poison. If poison reaches expiry date, will it get more or less poisonous? Poison and expiry dates. There's a funny thing that you see sometimes. You go to a supermarket, you want to buy Himalayan pink salt. So you will get a box, a tin, whatever, of Himalayan pink salt. On the label, it will say, this is pure Himalayan pink salt. It is more than 200 million years old. More than 200 million years old. And then it will say expiry within 6 months of manufacture. Does it make any sense? Something has been around for 200 million years, but it's going to expire in the next 6 months or next 12 months. So what I'm trying to say is that very often these expiry dates have no meaning. When you produce a food product or some other product, sometimes or oftentimes by law, you are required to give a specific expiry date. But that expiry date may sometimes just be for the sake, for namesake. I remember reading some time ago, that scientists discovered ancient medications from the 1940s, etc. Strips of tablets and all that, and they tested them for efficacy, and they had expired decades ago, but they were found to work just fine, even though they had officially expired. So very often these expiry dates don't mean a lot. Yeah. Now, obviously, I am talking about food products and medicines, not poisons. So it depends, I would say. Certain poisons are chemicals, essentially. Yeah. Certain chemicals have a certain amount of stability, and if they come into contact with moisture, for instance, or heat, they may degrade, and their chemical composition may change, possibly, or their efficacy, potency may decrease over time. So it depends. So I don't know if all poisons will become less poisonous after expiry date, or even if poisons do have expiry dates. I'm not sure, right? Potassium cyanide is one of the scariest poisons we know of, right? One of the most infamous poisons, potassium cyanide. Does it have an expiration date? It's just KCN, right? The chemical compound. I don't think it expires, but does it react with moisture? Maybe it does, maybe it doesn't. I'm not quite sure. I'm not quite proficient in chemistry and all that. I would say that poisons would eventually, depending on what they are made of, would over time lose some of its potency. Let's say you have rat poison, or we spoke about cockroach poison. If you open the wrapper or whatever it comes in and you leave it open for a month, maybe it may not work after a month, maybe. So typically over time the efficacy would decrease, but in some cases it may also not. We don't know. So yeah, it depends on what it is made up of, and more or less some of its efficacy may decrease, possibly. All right, that's about poisons. I think I will now take some live chat questions for a few minutes. All right. Do we have any live chat questions? If you have any, shoot away. Okay, people ask me questions about history, about geopolitics, about current affairs. Today is science. You have questions about science? Go for it. Okay, someone is saying, okay, I am not getting any science questions. I'm getting all kinds of other questions. Saddam Hussein, Chinese spy ship, 24 election. Why have you stopped taking live questions? I just took a live question, sir. Ask me a question about science. How do we sleep? And there's a question. There's a representation of a sleeping person here. See, where is it? Here, here. How do we sleep? We sleep with our eyes closed, and we fall out of consciousness, and we enter a zone or a state of altered consciousness, which means that we are not aware of our surroundings, but there's something else going on in our minds. We call it dreaming. And most often, in most cases, we tend to forget what we were dreaming. We do remember we had an interesting dream, and we wish we could remember it, but mostly, in most cases, we forget our dreams after we wake up, within seconds typically of waking up, unless the moment you wake up, you put your mind on that what you were dreaming about. So that is sleep. It is a state of altered consciousness, of unconsciousness, essentially. And there is this phase of REM sleep, rapid eye movement sleep, and there are various kinds of brain waves associated with different phases of sleep. There are sleep cycles. I think it's 90-minute cycles in which you have a complete sleep cycle, and so on. It's not very well understood why we need sleep, and so on. Maybe we are consolidating the memories that we formed during the daytime. Maybe the brain needs a spinal fluid bath to take away the impurities or whatever else. And if you don't sleep enough, you may have the formation of amyloid plaque in the brain. You may be more susceptible to dementia and to Alzheimer's disease, etc. So these are the things about sleep. How do we sleep? That's how we sleep. Go lie down, close your eyes, and eventually we'll drift off to sleep if the time is right. That's how it happens. Okay. Anything else? What are the implications? What implications would be the existence of the line of evil in the cosmic microwave background? What can be the possible uses of antimatter provided we can store it? I have never heard of any line of evil in the cosmic microwave background. Never heard of it. So, yeah, I don't know that. Uses of antimatter. You could use antimatter to produce energy. You take a bunch of antimatter, you mix it with regular matter, it will immediately annihilate itself and give off pure energy in the form of, mostly I would imagine, photons, yeah, and heat and all that. And you could harness that to produce for propulsion, for like a nuclear reactor, for instance. You could use it for weaponry, and so on and so forth. Yeah, so it could give you pure energy, which you could use in any way or shape or form that you want, if you can store it. That is the major problem. The number one problem is how to make antimatter. It's very, 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 very hard to make antimatter. uh, it's the most expensive substance you can imagine. And secondly, how to store it, because it's very hard to store it. Right. And again, people are asking me questions not related to science. I don't understand why they do this. How did life start on Earth? It's a major, massive mystery. Abiogenesis, right? So we don't know, but it is believed that because of the conditions of the very early planet, a lot of lightning and the mixture of gases that you had, and a very wet environment, and this entire mixture of factors, this combination of factors conspired to brew amino acids that became the precursors of proteins. And then somehow this mysterious molecule called DNA appeared from somewhere. And then all of this mixed together to form the first life. That's what is thought, that's what's believed, but we don't quite know for sure how it happened. This theory is called abiogenesis, the emergence of life from non-living matter. Okay, do we have anything else? I've taken many of these questions multiple times. Um, Yeah, I guess that's it then for now. We have crossed 2 hours, so I'm going to end it here. Thank you very much for all the questions. I know there are lots of other questions. We'll keep taking them. And please look at my older videos, and many of the questions you're asking me have already been answered. But anyway, I'm happy to keep answering your questions. Keep the questions coming, and we will keep answering them. But for today, we are done. So I will see you in the next episode. Until then, take care and bye bye.